Yeah, so welcome everyone to this webinar about industrial computers. And you can see the agenda in front of you. I will just start here. And my name is Johan Kastensson. I'm a sales manager here at our vision department at OEM Automatic. And I will do a short introduction about OEM Automatic and our vision department. And after that, we will have a product manager for Newsys, Chris Nee, who will talk about his computers. So during this webinar, you will be able to ask a question, and you can use the question tab on the go to webinar application. So send your questions, and then we will take all the questions after the presentation. So feel free to ask questions to OEM Automatic and also to Neousys. So we will jump directly into OEM Automatic, and just a really short presentation here about OEM Automatic as a company. We are about 170 employees. We are located in almost 20 countries around in Europe, and we also have one office in China. And we're working especially for industrial components for automation, but yeah, we're covering almost all techniques right now. OEM Automatic as a company and our marketing strategy is to be a market maker. It means that we should have the latest technical products and have the latest knowledge, and be able to be a hand between our customers, which are mainly based here in Northern Europe, the northern countries, Sweden, Norway, Denmark, Iceland, and some parts of Finland as well. And with our local knowledge, we will be a good hand to help out our customer to run and develop projects, and we can help our suppliers to find these customers and making good cooperations. And it's quite often that we come to a supplier with a custom need that they can, from a customer, that they can build up, and we can have a new product developed together. We also have a really big logistics center here in the middle of Sweden, which is in Tranås, where we ship out a lot of boxes each day to all locations here in Sweden, Denmark, and Norway. This is a picture of our team right now. We have Torbjörn Fjorde, which is our product manager at Vision Department, and myself, and we also have Andreas Kjellming and David Persson, they are product managers for cameras and for 3D applications. On the sales side, we have Matthias, which is responsible for some parts of Sweden and also Norway, and Torstein, which is our Danish colleague, which are working from Sweden, covering south part of Sweden and Denmark. Elof is our support tech guy here, which handled most of the support and building computers at our office in Malmö. And Jesper is our purchase and sales support, and yeah, he pretty much taking care of us and make sure that we can get things to our warehouse and we can ship them out. So this is the team you will meet up when you talk to OEM Automatic. As a vision department, we try to have all the other products that you need in a vision application. For example, cameras, which is one main component. We're working with Basler, Sony, and Matrox, for example. In the 3D section, we try to cover all different solutions like structured light from Photoneo, time of flight from Basler, laser triangulation from Matrox or Smart Ray, or Also a time of flight from Gigabyte, and we also have some stereo vision solutions from Neousys. Together with that, we also have some interface solution from Twiga, Pliora, and Ionodes. If you want to connect like a more IP camera to a vision application. If you go to the software part, we're working with Matrox, PCAT as an AI software, and also some Photoneo softwares for bin picking, and also AI random bin picking. Together with that, you also need to have a lot of different lenses, illumination, filter, enclosures. You can find pretty much everything at our webpage. But if you find something that if you don't find anything you're looking for, just contact us, because it's a lot of things to have on the webpage, and we are really glad to find products that we don't have in our webpage as well. Finally, up in the right corner, we also have the industrial computers, which is the topic we should cover today. And we're working together here with Newsys, and we are really glad that we can be able to host this webinar today, where we can present the latest technology and these really good computers. We have been working with Neousys for a really long time and have really good cooperation, and they have a really wide portfolio of vision-based computers and a lot of other stuff that we will be talking about today. So this was a really short presentation from OEM Automatic side. You will all be able to contact us afterwards, and as I mentioned in the beginning, if you have questions during the presentation, just feel free to add them in the chat in questionnaires in the application, and we will take all the questions after in a Q&A session. So with that, I would like to introduce Chris Nee as a product director for Neousys Technology, and let him start his presentation. And I hope everyone will enjoy this hour, then we will be talking about computers. So Chris, feel free to start.
Thank you, Johan. Good morning. I'm Chris Nee from Newsys. First of all, I would like to thank our very important partner, OEM Automatic, to host this webinar, so we can share our perspective regarding the HA applications and the platforms. In today's webinar, we'll use several applications to show what's the right or reasonable AI inference hardware and the platform selection for the edge. This is the edge agenda today. We'll start from the overview picture of the edge AI and talk about the challenges and requirements when you want to deploy a real edge AI system. Then we share several successful use cases and their corresponding platform selection. Finally, we'll have a Q&A session, so you can leave your questions in the question text box, and we'll answer them. Before we go on, let me spend a few minutes to introduce Newsys. Newsys is an IPC company dedicated for rugged, application-oriented platform. We were founded in 2010. We have headquartered in Taiwan and 2 branch offices in USA and China. Today, we have over 30 distributors and value-added resellers worldwide to serve our customers. Newsys has 5 main categories of products. The first one is the rugged embedded box PC. They are designed to work 24/7 and from the -25 to 70 degrees Celsius environments. We also have a very unique machine vision product line. In addition to those PoE or USB 3 frame grabber cards, we have a very special vision computer that integrates LED lighting controller, a real-time trigger system for camera and light, and the camera interfaces, and even the GPU support for inference, all inside a very compact small vision computer. The next category is the edge app platform. This is what we are going to talk about today. They are GPU computers designed to run in harsh environments of extremely high and low temperature or intensive shock and bind. Other two categories are in-vehicle controller for in-vehicle applications and the x86 or ARM-based information gateways. This page shows some milestones of our rugged Edge AI system. You just notice the red box. We introduced our first rugged GPU computer, Newsys 5095 GC, in 2016. At the same year, we start to work with Baidu for its Apollo project. Apollo project is an open source autonomous driving project. Next year, in 2017, we introduced the Newsys 6108 GC, and it became the only reference hardware for Baidu Apollo's Level 4 autonomous driving system. Till today, we've become one of the leading companies provide the truly rugged AI platform for many AI applications. Okay, let's look at the Edge AI. Edge AI is actually the combination of edge computing and artificial intelligence, which means you want to run in AI in some places close to the real data input, and the environment can be harsh. If we look around our daily life, actually you can see AI everywhere. For example, your bank use some AI models to determine whether your credit card transaction is a fraud or not. And Google, we all know Google use natural language processing models to translate your voice to text and try to understand what you really mean. Social medias like Facebook or YouTube, they use another AI model for their recommendation system. So they can deliver the contents and advertisement according to your web serving histories. They are the AI applications happen in the cloud or the data center side. We also see a lot of AI applications at the edge. For example, we use a lot of AI technologies for autonomous driving and robotic taxi. We also have AI models for facial recognition, for surveillance, and other inference models for roadside to vehicle communication. That's a part of the smart city. For manufacturing, we use a lot of convolutional neural networks for vision inspection. And we also know there are some other companies use the reinforcement learning to build their pick-and-place robots. So you can see here, Edge AI is an ongoing process that will change our daily life. This page, we want to talk a little about what's the benefit putting AI at the edge. They are very straightforward. Because you do the AI inference close to the real data input, you can always expect a lower latency and a faster response time. And it can also save the overall deployment cost if you include the cost of data transfer into consideration. That means if you're close to the data input, you don't need to transfer a large amount of data to the cloud for further computing. Other benefit like you can have a smaller hardware devices and the lower power consumption. And running the AI at the edge can improve the data privacy and security. As Edge AI is happening now, what is the hardware we can use for AI inference? This table shows several popular AI inference acceleration hardware. The first two are lightweight devices. They are Google Edge TPU and Intel Movidas VPU. With a very low 2 watt power consumption. Both of them can deliver around 2 to 4 tera OPs, which is capable for a simple object detection or the voice-to-text translation applications. NVIDIA Jetson AGX is another low-power device. It consumes only 30 watts, but it can contribute over 30 TOPs for inference. So literally, you can run all kind of machine learning framework or AI inference applications on the Jetson AGX. And because it's a low power, it's very good for a lot of battery or solar power AI system. Okay, if that's not enough and you are looking for higher computing power, then choose NVIDIA GPU. You can have a wide selection from 75 to 350 watts with 2 to 300 teraflops computing power. So literally, you can run all kind of inference models within the GPU. Okay, now we are going to discuss about the AI platform at the edge. After we talk about the benefit of running AI at the edge, now we think about the challenges. When you're running AI in the real world, outside an air-conditioned data center, you may encounter a lot of environmental conditions. For example, the system may experience extremely high and low temperature, so your system must survive in this high-low temperature condition. Or you can suffer an intensive shock and vibration when it's placed on a vehicle or on a moving robot. And putting the AI in an outdoor environment, the power stability can be also an issue. And for some AI applications, for example, you want to have an AI system in a food production line, in mental processing factory, or the marine application. You may have issues with water, dust, or salinity. These are challenges when you want to run an AI system at the edge. So here, we want to show you all the ideas when we design our rugged GPU computer for edge AI applications. There are a lot of details here. The first one is we want to have a complete GPU support. So now we have platform to support the cost-off-the-shelf RTX GPU or the Quadro or Tesla GPU. And we also have the platform running the Jetson AGX for low power applications. And all of our platform has a pattern thermal design, so we can guide the intake air and the exhausted hot air with a very regulated way. So the result is we can guarantee 100% GPU performance and high ambient temperature. So that's very important, because when you want to have an outdoor AI system and it's hot in the summer, you may suffer the degrade of the GPU performance. And we also have a very unique and patent GPU holding bracket to keep the GPU firmly stay with the golden finger connectors. So it's very useful when you deploy the computer on a car or a moving robot. We also have a patent damping bracket. It's also helped to withstand to a 3G vibration in operating condition X, Y, Z axis. And we also have a very solid and reliable power, DC-DC power design. So we can support multiple GPU with single wide range DC input. So this design simplifies the power supply, and it's very easy to battery powered application. We also have the built-in ignition control. So it's benefit the application when you want to run the AI on a vehicle. other details, including we have the rich I/O with screw lock. So you can notice that we can even keep the cable safely connect with the system in all kind of circumstances. We also provide a lot of expansion capabilities. So if the built-in I/O functions are not enough, you can have the functional expansion with additional I/O cards. This is our trick when we design all the Edge AI platforms, and this shows the overall portfolio of our GPU as our Edge AI platforms. So you can see we offer the power efficient or low power devices for Jason Xavier AGX and the Google GPU or the Movidas VPU. We also have the system designed for automation, factory automation. So they are the compact system with a low cost or mainstream GPU or with a lot of expansion slot for additional I/O devices. We have the high throughput inference computer work with the Tesla T4 to give you the computing power for high throughput inference. We also have a system to accommodate 1 or 2 high-end GPU cards, that is the RTX 3080 or the latest RTX 5000. That gives you a tremendous horsepower for both inference and training at the edge. For demanding environments, we also have a very, very unique, that's the fanless or waterproof GPU computer. It's a rack mount design with the IP67 waterproof capability. And with the Tesla T4 GPU support, you can do a lot of inference models for agriculture or the mining business, or even a more harsh environment. Okay, this is the most interesting part today. Then we will use several successful use cases from our customer to talk about what's the application requirements and what's the right inference hardware and the platform for this kind of applications. The first one is a battery-powered warehouse AGV. Okay, you can image there's some robots or AGVs moving around in a warehouse. So this application, they want to use the AGV to carry goods from position A to B with mid to low speed. Unlike autonomous driving, usually the AGV move in very, very low speed. It's just like the human walking speed. Okay, so this AGV shall have the capability for self-route planning and obstacle avoidance. So which means you should have intelligence to identify your surroundings, objects, and plan the right route. So the consideration for the inference hardware and the platform is because the AGV is usually the battery powered. So low power is a very important consideration, and also the DC input. And because the AGV shall have the capability for surrounding recognition, so it should have the reasonable teraflops or teraOP for object detection. And because the vision is the most important sensor for this kind of applications, so you should have the image input from industrial or automotive camera. Here, I want to talk a little about a camera. You can image in a large warehouse. The illumination condition can be varied, which means if you use a fixed shutter, fixed scan industrial camera, you may have you can have poor image quality in some position. In this case, the automotive camera can benefit you. The automotive camera is what we use for car. So it supports some interesting feature like HDR, high dynamic range, or the LFM, the LED flickering mitigation. So it can have a better image quality with variant illumination conditions. So that's why our customer choose the NRU 110V for their warehouse HEV. Because this is a system, it's a family system running with the JSN Xavier AGX. It supports 8 GMS, or camera input, that's the automotive camera, and has the built-in CAN bus and DIO for some control purpose. So the whole system has a less than 50 watt power consumption, so it's good for battery powered. It contributes 11 teraflops in FP16 or the 32 tera OPs in INT8, and support automotive cameras for variant lighting conditions. So that's a good case for in-house the in-house battery powered HEV. Some other of our customers consider even more low power devices. That's the AMD, that's the Nuvo 2700. It's an AMD CPU and support 2 Google H TPU. So basically, it's the whole system consumes less than 30 watts, and you can have 8 tera OPs with 2 HTPU, and use the GD or USB 3 cameras for stable lighting condition. That's the case for the HEV. The next application is a more popular one. It's a production line vision inspection. So all we know for vision inspection, we can use the deep learning, or more precisely, a convolutional neural network to detect, identify, or classify objects. And the system should collaborate with other I/O cards or PLC, so you can build a fully automated system. For this kind of application, your consideration should be cost effective, because we all know that when you run something in production line, you need to consider about the mass deployment. And you usually use the industrial camera for image capture, because we can control the illumination condition with the LED light. And the GPU support plus the frame grabber and I/O and motion card are important for automation system. And the most important one is it should be reliable, because usually the production line is a 24/7 operation. For this case, we have a lot of customers use this kind of edge AI platform. Like we have the Nuvo A03, we have the Nuvo AT34. They are the latest Core i7 system with different kind of GPU support. The 8003 support the mainstream GTX 1660 GPU to give you 5 teraflops for inference. And there's additional 2 PCI slots for frame grabber cards or camera link. The AD34 is a more expandable box PC, supporting additional 3 PCIe and 2 PCI. So in addition to PCIe frame grabber cards, you can even have the PCI slot for motion control. So a single system, you can do the imaging, the vision inspection, and the motion control. We have some customers using a more compact one. It's the Nuvo 7160 GC. That's a more compact one supporting the GTX 1660 GPU. And with the built-in 6 GDE or PoE interfaces and 8 USB 3, this system provides 5 teraflops with PoE and USB 3 for cameras. And we also have our proprietary Meso interface for I/O expansion. Okay, for production line vision inspection, you have a wide selection of the GPU computer, depending on your need requirements for interfaces, the expansion capability, and the GPU. And this is another application we have. It's the outdoor intelligent video analytics. For this application, our customer want to retrieve the live H.264 video streams from many IP cameras. And the system shall decode inference and visualize all the images in a processing pipeline. So when you consider this kind of application, the system should have a superior H.264 or 265 decoding capability, because that's the video stream from IP cameras. And it should provide superior teraflops to perform multiple inference models, like you can do the facial recognition and the pulse recognition at the same time. And the system, because the mainly surveillance system are running outdoor, the system should have stable performance at high load ambient temperatures. For this case, our customer choose the system with the Tesla T4 GPU. We have two models. The first one is the 7166GC that support a single Tesla T4 with the 6 GG PoE input. So the system can support up to 32 video stream and 65 teraflops for inference. And there's no GPU throttling at 55 degrees Celsius ambient. If single Tesla T4 is not enough, then we have another model, is the 8240GC, which is the called i7 box species supporting 2 Tesla T4. So now you have 64 H.264 Full HD decoding capability, 130 teraflops for inference models. And again, no GPU throttling at 50 degrees Celsius. Okay, the next application is what we very familiar with. It's autonomous driving. As I mentioned, we start to work with Baidu Apollo since 2016. So till today, we work with many software or car company dedicated for autonomous driving. So this page shows the fundamental functional block for autonomous driving. The first part is the camera or sensor hub. For autonomous driving cars, you have a lot of kind of sensors to retrieve the data surrounding the car. There are a lot of sensors, like camera, that's the most important one, and LiDAR is the most reliable one. And other sensors like millimeter wave radar or the GPS or IMU for positioning. So once you have the sensor input, you need to combine them. There's a terminology called the sensor fusion. That is to collect and align all the sensor data and put them into the inference models. Okay. The second functional block is the perception. That is the function to run multiple models. For example, there is typically maybe 20 or 30 models running simultaneously in an autonomous driving car to identify, for example, the lane, the traffic light, the people or other objects on the road. Okay. Once you finish the perception, you understand what's surround you. Then you go to another functional block called planning. There are some rule-based algorithms to determine what's the next step to take, what's the action to take according to the result of perception. Okay. As you can image, this is a very complex system. So for Newsys, we have different products for different functional block. The first one is the sensor fusion box. We have the Nuvo 110B, because this unit can collect data from different sensors, like the 8 automotive cameras. We have DD for LiDAR inputs. We have CAN bus for millimeter wave radar. We have the GPS PPS input for time synchronization. We can do the sensor fusion by either trigger, there's an internal trigger mechanism, or the time stepping. Okay, then once we collect the data and finish the sensor fusion, we can stream in the data to perception unit by its 10G Ethernet port. that's provide enough bandwidth for all the data transmission. And then we have several models like the UVO 8208GC or 8108GC that support single or dual RTX 3080 GPU. So you can have up to 60 teraflops for inference. Because you are running multiple inference models like object detection with distant info information, with the land detection model or the traffic sign recognition models, you need a tremendous horsepower or teraflops for inference. And because all the system must be installed on a car, so the vibration resistance is also important. And then once you do the perception, you can transfer the result to a planning unit. So we have the in-vehicle controller like the 7200 BTC or 551 BTC. So you can run the rule-based algorithm to control the vehicle via CAN bus. Or you can communicate with the V2X, the vehicle to roll infrastructure via your 4G or 5G internet. Okay, the last application what we want to mention is the AI for demand environment. That's the requirement when you want to run an AI system in a truly harsh environment. For example, the food processing line, you can suffer the liquid, you can have the fluid spill. And for example, the robotic agricultural mining, you may experience a lot of dust or extreme heat. Or the seaport and main crane control. On the seaport, you can suffer the water or salinity problem. So when you want to run the AI for demanding environments, you need IP67 for water, oil, salinity protection. Or if there's only dust, then you need IP40 for dust protection. And because it's a fully fanless system, so the system shall have very good passive heat dissipation capability for GPU. Otherwise, you will suffer a significant performance degradation at high temperature. For this kind of applications, we have Samuel series. So we have the Samuel 3000, that's the IP40 fanless GPU computer, supporting up to 65 teraflops using Tesla T4, or the 4 teraflops using the Quadro P2200, and no GPU throttling at 62 degrees Celsius in fanless condition. If fanless is not enough, we have a Samuel 1700 GC series. That's the IP67 waterproof GPU computer. Again, with the T4, you have 65 teraflops and 4 teraflops with the P2200. And again, no GPU throttling at up to 62 degrees Celsius. Okay, this bring me to the end of my presentation. Yeah, thank you for your time and attention. Here we come to the Q&A session. So Johan, it's your session.
Yeah, thank you, Chris, and really informative. And yeah, so I think we jump right into the questions. We have got some questions so far, but if you have anything you think about, just write the questions in the chat, and we will try to answer them here in the webinar. Yeah, so we got some general questions first from to OEM Automatic. So I will start to answer that by myself, Chris. So okay. One of the question is, are you able to do physical visits to customer right now? And yeah, we follow all the regulations that are from the government, and we try not to do that, but if we together with the customer feels that we can do it in a safe way, and it's really necessary, we will handle that individually. And another question we have here: do you have any demo units for testing? And yeah, of course, we have several different models available in our demo lab, and we can also make some. We can borrow things from Newsys if we need something specific. So we have some GPU computers and some more standard vision computers for testing. So just feel free to ask us, and we can probably solve a lot of things here quite fast as well. Yeah, so now we have some questions to you, Chris, and
okay.
we can start with things concerning the NRU solution with Javier solution and the GMSL cameras. Will you mentioned you have some cameras available, but will it be possible to use third-party GMSL cameras in your applications?
Unfortunately, the answer is no. The reason is because when you run in the GMSL camera within the NIU system, it involves with very sophisticated driver architecture. So when you want to retrieve an image, you need to finish all the driver development for the CMOS sensor, the GMSL deserializer, and there are some fundamental driver framework like the video for Linux. So once you finish all of them, then you can use some common tool like OpenCV or the GStreamer to retrieve the image from the GMSL camera using a single API. So far we only support 2 GMSL camera. One is the OnSemi AR0147. Another one is the OnSemi AR0231. Okay, that's so far there's 2 GMSL cameras we support. But with our future product enhancement or enrichment, we will support more and more GMSL cameras.
Yeah, thank you. And a follow-up question about that. From what I know right now, you have the GMSL standard, but people also talking about GMSL 2, which is more bandwidth. Or can you explain a little bit more about that?
Yeah, that's a very good question. Okay, I can share with you. We have an ongoing project to design a GMSL 2 product. That would be the JSON-NX with 4 GMSL 2 input. So with the GMSL 2, yes, you can have a higher bandwidth. So we'll support more cameras from 1 megapixel, 2 megapixel, 5 megapixel, and up to 8 megapixel. So if we are lucky enough, you will see it by the end of 2021.
Yeah, and besides the more megapixel, what will be the more advantage of using the GMSL 2? Can you get more frames or lower latency, or what will be the result?
Okay, that's another good question. For autonomous driving or HEV, there is an important factor is the latency. So when you get the image, the latency between you retrieve the latency and finish the inference determine how fast you can move. So with GMSL 2, we can have the camera with 60 frames per second. That is, we can expect the latency between the image input and the input for inference model below probably 70 to 80 milliseconds. Today we have the number of 1 to 120. And with the GMSL 2, we can shorten the latency to 70 to 80 milliseconds, which means you can move in faster because there's a shorter latency.
Yeah, thank you. And so right now, if I want to go with higher frame rate, it's the GG interface I can use on the NRU solution. So it's providing 10 gig right now. Is that enough to have a reasonable frame rate in like if you use like 8 cameras or something like that?
Yes, we can do a simple calculation. To support the data streaming from a 1 megapixel camera, the data rate is about 360 megabyte per second. That's only 30 to 40% of the 10 gig Ethernet bandwidth. So we have the 10 gig Ethernet, then the bandwidth is quite enough to transfer the data from a GMSL cameras.
Yeah, and regarding this Javier HES solution, is it possible to connect the I2C sensor and then access the GPI pins that is possible to access on the dev kits from NVIDIA?
For our NRU products, we have the GPIO, to be more precise, it's an isolated DIO. And we also have a PPS input from GPS that's used for synchronize the distributed system. But unfortunately, we don't have the I2C interface. But we will take it into consideration when we develop our next product.
Yeah, that's good. When we already talked about development, I guess this NRU solutions quite often can go into cars or into other vehicles. Any plans for making this NRU solution as a IP67 solution together with the cameras, like the CMIL computers?
You mean for the NRU series?
Yeah, exactly.
Okay. Yeah, that's another secret. Yes, we have another ongoing project to do this.
Yeah. Okay.
So there will be the NRU series with the waterproof FRACA interface for automotive cameras. We have also the M12 interface for the GIG or 10 gig Ethernet.
Yeah, perfect. We had a lot of questions here about the NRU series, which is really interesting.
Yeah. Yes.
We also, you mentioned in the presentation a lot of that you do thermal testings and you mentioned operation temperature. Can you explain a little bit more about how you do these tests and how you make sure that the things works?
Okay, this is very good questions. We all know that the GPU is a device that consumes a lot of power and generate a lot of heat. So when we design the whole system, we need to consider about both the power and heat. Okay, so there are two parameters for GPU. One is called the TDP, that's the thermal design power. Another parameter is the EDP, that's the electrical design power. So the EDP defines the transient, the power transient of the GPU can consume, and the TDP define the heat that the GPU can consume. So what we do is we do a real test. We're running the stress test using some deep learning model. Typically, we run the ResNet 50, and it's an infinite training loop to stress the GPU. So when you do the ResNet 50 training, it can consume the maximum TDP and generate a lot of power transient to the GPU. So we put such a live stress test to the chamber to run to 50, 60, or even 70 degrees Celsius. And we will watch and record the power consumption of the GPU. Once the GPU throttling happened, you can notice that the 250 watt GPU may consume only maybe 200 watts. That's we call the GPU throttling. So we can provide customer a number. It's a temperature that's under the temperature criteria. there's no GPU throttling when you run the GPU stress testing. That's how we do the thermal test for our system.
Yes, thank you. It sounds like it. We can trust on your ways to measure here. And so we have a final question here, and that if we look at in the future, you mentioned a lot of. Right now, it's the NVIDIA Jetson. We're talking about these powerful Tesla graphic cards, and we see on the market that it's a lot of customer chose to develop things on like other processors. Can you mention a little bit from your R&D or behind the scenes, what in your roadmap, or what is the future? What do you think will be the next big thing? If we say right now it's the graphic cards and Javier, which is the big thing that happened right now, what will be the next step?
Okay, my observation is we will go to two directions. One is a more and more powerful GPU devices plus a more and powerful CPU devices. Another is go to the extremely low power. Okay, for low power parts, it's a important feature to deploy the AI to the edge. Because a single system consumes 200, 500 watts. It's not a good idea to deploy to the outdoor environment. And we also noticed that there are a lot of AI technologies are developing, like the quantization or the data pruning. That's the technicals to reduce the complex of the AI models. So you can run the same model with a more smaller or lower power inference hardware. So that's the idea why we support the Movida's VPU or the Google GPU. So with the improvement of the AI technology, we believe that someday you can run a very complex model into a smaller low power AI devices. That's the direction for the low power. Then another direction is the mix of high power CPU and high power GPU. So we believe that there will be a good balance between CPU and GPU. If you look at today's product, we have a super powerful GPU, but it's a relative not so powerful CPU. So what we're going to do is we'll give you a good balance for the mid-tier GPU plus a mid-tier CPU and high-end GPU mixed with a high-performance CPU. That could be a server multi-core up to maybe 64 or 128 cores CPU. We believe a good balance will have better efficiency for the AI applications.